Trees can't tell jokes, but we can certainly tell stories. This is good. This is good. I'm gonna go make a tree. Alright, we are here for another new project for Tech Ed Online. So, welcome to the metal side of the Tech Ed Lab. And I, as you saw before, I'm going to make a tree. Okay, what does that mean? Well, how I'm going to do it is I'm going to take metal. Okay, this is 14 gauge mild steel sheet metal. And I'm going to use this plasma cutter. And I'm going to cut it out. So this plasma cutter is shoved in a closet, but it works great. It's connected to 220 volts of electricity. And then it also is connected to an air line that comes through. All right. And then it's basically the machine right here in this box. There's an on-off switch. You can adjust the amperage. I don't mess with that. I just keep it at this setting. And then it comes with a torch handle. All right. So what's a plasma cutter? Well, essentially what a plasma cutter does is it takes air in combination of electricity and they create plasma when you put them together at high pressure, all right? And then that plasma will instantly cut through metal. Like it's really crazy, super powerful, a lot of fun to use, but it's a very useful tool, a lot safer even than the torch. The oxyacetylene torch, because you're dealing with hazardous or dangerous gases that are flammable. Here we don't really have flammable gases. We are taking metal and instantly turn it into molten metal, but it is still dangerous, but a little less than the oxyacetylene. But anyways, I'm gonna cut out a tree and you can watch me. Put on these here. One thing that you need, it's a little bright, so I'm gonna use these. And then these are just some shaded, I think level 6 shaded glasses. These are level 5, but not as much as the welder because it's not that bright, but it's still pretty bright. And then I need some gloves. And now I'm gonna cut myself out a tree. Here we go. Turn the machine on, use my welding table. It's grounded just like the welders, but it's not a welder. Here we go. Turn on for me. Bongo! How do you like my tree? Does it even look like a tree? What do you think, Bongo? He's not saying much. Wow, what a beauty. Doesn't look that great, does it? I think I'm gonna try something different. So what this plasma table will do, it's basically just like the plasma machine you saw in the cabinet. Here's the plasma machine. I have my electricity here. I also have my compressed air going in. I can adjust the amperage here, but Also, this is hooked up to this computer, which is hooked up to my big screen TV right here. But I use software in this computer to make designs to generate G-code, which is just a series of numbers that will control this machine. And this is on a Cartesian coordinate system, so that's how it generates the numbers. Right here I have my x-axis going this way, and then I have my y-axis going this way. Now if there's a third dimension, it would be z, and it'd be going up and down. I can adjust this going up and down, but it doesn't move on its own. And then there's also a torch. This would be where the handle is that I held with my hand, but this is just set in this mount right here, but it's the same as the torch handle. Nothing different than that machine there, except for this table right here. Now what's unique about this table is filled with water. It's called a water table. And what's nice about that is that when this machine gets turned on and starts cutting metal, that just like welding, there's fumes that are generated that get airborne. And it's not good to breathe those in, nor is it good for anywhere in the environment here. You need to have an exhaust system. But with the water is actually more effective than the exhaust system. And if you look, this water is really dirty. Doesn't need to be clean, I'm not drinking it. But all the particulates and pollutants get trapped in that water instantly because of the surface tension of the water. So it actually makes it really safe, and that's why you see this machine right here in the classroom with all the other CNC machines. So now we're gonna move over. What I'm gonna do is I'm going to design a tree. All right, everyone, so here I am on the computer, and what we're gonna do is I need to find a tree, and then I am going to import it into the software that we use for the CNC plasma cutter. I never said the name yet of what it is, but it is a CNC plasma cutter. Look that up here real quick. CNC plasma cutter. See what that is. I'll have that be a word that you look up, but there's lots of different plasma cutting machines. Some are really big, like these ones here, or some are kind of small, like my one that I have. And basically, the area that it can cut is the maximum size material that you can use. So in our case, I can use a 2 foot by 2 foot area to cut. Some of these machines are 4 foot by 8 foot, like our ShopBot router or CNC router, all different things. But these are awesome machines. Okay, really precise, and they cut metal really fast, and I like it. Really fun. But going back to it, I wanted to find a tree. Well, I do have a bunch of files that I've already have preloaded, and with these files, let me find them here real quick. There's all kinds of stuff, and I was going to introduce this to the 8th graders during our entrepreneurship class, as well as our metals class, so that you could see some of the designs and different things. There is a lot of files here, so let me go to the image part so you can see these files. And I have all kinds of stuff. So you could go, all right, I want to make a moose art. No, let's do something. I want to put something on top of my mailbox. I'll find a mailbox topper. So we go into these images, and they're not labeled, so that kind of stinks. But I can come in here. All right, here's something I could attach to my cutout with metal. All the black would be the metal part. And then right here is a bracket that you would use to attach to your mailbox. So this is just one of hundreds that I have. So we can make mailbox toppers or all different, unless you bring in pictures, and then you can use the trace function to outline those pictures and create vectors and all that stuff. I won't get into the nuts and bolts of that. Take metals, take 8th grade next year, and we'll get into that a little bit. And intro to tech ed, we get into vectors and this type of stuff. Okay, so there's tons of things in here. So what I want to do is find out what tree we want to use. So there's actually a file folder with tons of trees. I could go online, type in trees. Like if I went on here, somewhere here. I'll just type in tree, and it kind of helps if I put in vector or if I put in black and white. I could go to images, and then I could find a tree or an outline of a tree. The problem is a lot of these are really intricate and detailed, and the plasma cutter has a really wide cut mark. So these details, they don't come out as nice, okay, unless you're making it really big, which we only have 2 foot by 2 foot, so we can't really do that. So, but anyways, I decided to go through the trees, looking up in here, looking up tree files. There's all kinds of tree files. However, at the end of it, there's a file with all the trees available, or what's in the, hide this, what's in the package. So there's not many there. Hold on one second. Right here, let's check this out. So here's all these crazy trees. And I was able to find one. And fast forward here, I won't go through all these, but I was able to find one and bring it into my software. I think it was 173, this one right here. So I really liked this tree. It has a lot of details, though I'm going to have to go in and kind of customize this a little bit because it's a little too much of details for the plasma cutter. And you just know that through experience. If the plasma cutter came in and tried cutting all these, which it would try, and it would, but it would cut off branches and tree limbs, and it would ruin the trunk and all that stuff. So what I'm going to show you here is this is Bobcat software. So at this station in the lab, we have Bobcat, which this runs or works with the CNC plasma cutter. And then we have our ShopBot software, which works in combination with ShopBot and VCarve with our CNC routing machine, which is right on the other side of the computer here. But we want Bobcat, so I actually have it open here. With Bobcat, it's a super difficult program to run. It bothers me a lot because of how difficult it is. Every CNC piece of equipment we have in here has its own software. Sorry, I don't know if you can hear my phone in the background ringing, but please just ignore that. But the CNC software is all different for each piece of equipment in here, but they're all pretty easy to use. I mean, once you learn one of them, you intuitively can figure out the rest of them. You just got to find out where it is, but it generally does the same stuff. In this case, this software program is huge, and it's not made to run just a 2x2 plasma cutting machine. It can run an entire machine shop with CNC lathes, CNC mills, all kinds of things with like 6-axis from 2-axis all the way up to 6-axis. And so this is a really big program, and we are not even, I wouldn't even call scratching the surface of what we do in here. But so what I'm going to do is I need to import or bring in my file. These trees and 173. And here we go. Whatever, just bring it in. All right, so here it is. It's all traced out for me. These would be all the lines that the machine would come in and start to cut out. As you can see, there's some issues here. There's a lot of noise going up in these in this tree. There was over on the left-hand side, but I already cut some out, and I accidentally saved it to the original file, so that's why it's not showing up here. However, there's some gaps, and I had to do a lot of work to get this right. Okay, I had to widen up some of the branches. Branch was coming here. I had to thicken that up. I had to get rid of some of this crazy noise going on here, and that doesn't make much sense. All these like holes where the leaves would be, I had to take those out because they ain't going to come out right, or not going to come out right. So there's a lot of messing around with this, but it's still faster than if I came in and tried to design this whole tree myself, which you can do. But I have time is of the essence in my world right now, so I'm going to use things to be more efficient. So I found this person did the work for me. Don't need to reinvent the wheel. Manipulated a lot, and what I did is this was my end product. Hold on a second here. This was my end product right here. I took out a lot of the noise. I expanded a lot of the branches or thickened them up a little bit so they weren't so thin. I took out some of the stuff that's going through the trunk. This blue that's going around here, I already did some of the programming. This is the stock or the metal. This is what that would be. And I'm going to write some code. So you design on here. Then when you're done designing, just like all the CNC machines, you can move over to generating code. There's lots of different types of code. In this case, our CNC plasma cutter, it uses G code to communicate with it, or NC programming, but it's basically the same as G code. So CNC, what is that? We already talked about that a little bit. You'll have to look that up, but basically I'm using a computer and taking numbers to control a piece of equipment or a machine. So that's where CNC comes from, computer numeric control. So what I do here is once I got the stock set in, my design is all good, I need to generate some code. Now we can come in here and we can start working on all the different parameters and settings for the machine. Now we're just communicating with the computer, the software that's going to generate the code on what we want the machine to do when it's cutting. So first off, we got to select our geometry here, which is everything we want to be cut, all our lines. Second. Bam. Okay. I can hit next. And like I said, there's going to be a lot of settings that we don't even touch or even go near. I'm going to hit next a lot because this can do a lot of different machines. So there's lots of settings in here. But here's my tree. Hit next here. We only do profile cuts with the CNC, and I don't need two different types, so I can take one and delete it. We only need one profile cut. It's just going to follow all our lines that we made. Here we can go through, we can apply tabs, which are just little connections between each little cutout that it does, so that if you don't want it to fall all the way through or tip up or something, you can put these little tabs on there. We're not going to do that. These are all different settings that I don't want to mess with. Here we can control which side of the line. So if this blue line here is the actual vector or line of our shape, we can tell it, hey, we don't want you to cut on this line. We want you to be on this left side of the line. Or you can be like, no. We want it to cut on the inside of the shape, so we want it to be on the left side of the line. In this case, I'm just going to leave that off. I'll just have it cut right on the line. But this is a really important setting, left or right. Okay, it's depending on what kind of shape you want. But let's keep that off here. This is all stuff we don't need to mess around with. Lead-ins. So what lead-ins mean, the machine's going to start, and then it can start away from the shape and then come into the shape and then start cutting it out. I'm just going to do it with a vertical lead-in, which means the machine is just going to come in and blast right over the top of the line and then start cutting. I'll leave that there. I want sharp corners, sure. Starting position. This is just if you can doing many parts, you can control the order that it cuts out. I mean, really, it doesn't matter. I'm just going to hit X direction. Why not? Lead in and feed in rates. I want it to move twice as fast, so I'm going to double this up. Not that it matters too much for what we're doing, but all right. And then this is it. All those settings, we only changed a couple for what we're doing. Now I can hit compute. Give it a tick. It's going to, okay. All right, so now after I've did this cut and did the tooling portion, I can actually run a simulation to see how this would cut. And the simulation is pretty accurate. Here it is here. I don't like this view. I like the top view. And then it's on really fast. I'm going to slow it down a little bit. And then we can run it. I know the screen's really small, but this little blue dot here represents the cutter. And you can see it's going in the order that it's going to cut. So right now it's going to cut out the tree portion first, which I guess is okay. I kind of wanted to do all the middle stuff first, but I can change that order. It really doesn't matter. So I'm going to speed this up. There you could see it. All right, so at this point, what I want to do is inspect all my shapes and kind of see, okay, that's close, but it's not touching. And see how thick this cuts on these lines? And that's a good representation of how thick the kerf is going to be when we're cutting. I go to the post and save. This post and save will create the code, and then I'll be able to save it somewhere. Let's put it in plasma cutting projects, Wishtree. Yes. Replace. So now I'll generate the code. It takes a little bit. So just give me a second. There it is. All right, it's done. All right, so now we need to take our G code that we just did, and we have to get it over to this to the CNC plasma cutter machine. How we do that? All the other machines are directly connected with an Ethernet cable to the computer. So in this case, that's not so. Pretty much what we have right here is this handheld pendant, which is like a controller, and this has a USB port. So instead of that, we just use a thumb drive. So right here, I'm just going to come into my project. I'm putting it into a thumb drive. There it is in the thumb drive. X out of here. Now I can eject the thumb drive. There you go. Pull it out of here. Then it can come up to my controller and place it right in here. There we go. Okay. Now this is on already, but we'll get to that in a second. Okay, first thing what I want to do is select my material. I don't know if you noticed it, but in the lab here, I have a lot of material. I have all kinds of metal. I have lots of metal rods there, metal square stock that's down there, brass, most of it's steel. There's some brass there. I have more hanging up right here, pipe snap. You saw those with the campfire grill. But then I have lots of sheet metal and different things, stacks of them under here. So what I like is this. I pulled this out. It's kind of thinner. It's not like 1/4 inch material like this over here. I have some really big pieces here, really thick. These are super heavy. Like I can't even pick that up myself. So very heavy. This right here is heavy, but I can manage. All right, so now we're gonna set up this machine, the CNC plasma cutter. One of the things that we have here is this torch head. Now, kind of like different size drill bits, we need the right combination of, they're called consumables, which are the components that are inside this torch head to cut through. It depends what kind of material that we're going through. So in this case, we have this sheet metal, and in order for me to do that, I need to take this off. So I'm going to unscrew this. I gotta be careful not to unscrew that. It's actually how I broke this machine once. And then this comes out. There's all these different consumables and attachments come out, which is the electrode, there's a gas shield, all these different things. I'm gonna make sure I don't drop it in the water here. There we go. All right, so now we're over here. This cabinet right here is where I keep a lot of the tooling and components for this plasma cutter that I have sit here. So that's why this is here. I have my material and then I have my torch head components right here that I grabbed. All right, one thing that we need to know right away is the thickness of our material. And one thing that I'm going to use for you is this gauge. This is a gauge. It's actually a type of measuring instrument, and it is it can be used for wire, but it's also used for different thicknesses of metal. And what you do is you line up the metal and you try to see where does it fit secure the most or the best. So I'm going to take this and this and start seeing if it'll fit. That's too loose. That's too loose. It's getting tight. Can't do that one, so it's this one. On one side, it tells me the actual measurement, which is 0.064. This one's in inches, so 64 thousandths of an inch. And then it's actually a 14 gauge sheet metal. So this is useful. Let me know that. I need to know what that is. All right. Now that I know that this is 14 gauge, I need to find out what combination of consumables I need. If you look, there is a bunch of different things inside this head. There is a deflector, this is called, to deflect any like spray or debris going back up into it. I'll leave that connected because I don't need to change that usually. This gray thing is called the gas shield or the shield cup. Then this on this end right here, this is a tip called the tip. And then this right here is this right here is the starter cartridge. And then this right here is the electrode, the thing that actually is doing the majority of the work when it's generating the plasma. So these are great. One second. I want to make sure I keep them in the right combination so I don't mess them up. Just like that, just like that. Okay? But there's lots of different types of electrodes and combinations here. What I have on my box is a chart. Now this chart is very convenient. It tells you, okay, what kind of material are you using? So this one here is aluminum, but we're not using aluminum. We'll get to that. How many amps are you going to be using? Then you can look at this combination, and based on, you know, the gauge of the metal, or the type of metal more so, it'll tell you the combination of the consumables that you need in the head in order to make a successful cut. In this case, we're using mild steel. Mainly the metals that it can cut is stainless steel, aluminum, and mild steel. We don't do much more than that. But look in here, let's see, 60 amp mild steel. So what I need, I'm gonna get new consumables because these, even if these are the right ones that I need, they're really in rough shape because I haven't changed them since I bought the machine. So we're gonna change those out. In these black boxes here in the machine, or in the box, I have consumables. And they're filled with all kinds of crazy stuff. Extra gas shields, clips, basically everything you need to keep replacing your parts. Relatively inexpensive, but when you start accumulating a lot, it can get pricey here. So, first thing I need to do is I need a shield cap. This shield cap is pretty rough shape, so I'm gonna grab another one. There's a shield cap. Got it. My shield cup is fine. It's just a housing, so it doesn't really go bad unless it physically breaks. But my tip here, I definitely want to change because that's looking rough. I need a 98210. So let me find that one. 8210. Double check here. Yeah, 8210. So this is what I need for that. Drop that in there. This item right here, which is the starter cartridge, this is pretty functional and looks great. So I'm not going to change that one out. I can put that in there. However, you can see this electrode is pretty rough. All right. Sometimes they look rough right away, but you got to look at this tip right in the center, and it looks really worn and indented. Let me grab one that's good here. It's used. There, you can see the difference. All right. But I gotta make sure I have the right one. In this electrode, in this case, I need a 98232. 98232. 98215. 98215. Lots of 215s. Uh-oh. Maybe I don't have one. 98232. Brand new. All right, cool. I'll save the other one just in case, and we put that in there. Consumables are changed out. It's pretty simple as long as you follow the chart and get it set up right. My consumables all changed out here. Place it into the torch head. It just kind of pops up in there. There we go. Now I don't need to ream on it. It's not even snug. I just get it to where it doesn't turn anymore and stop. Make sure this is tight. Stop this tight. We're good there. Some other side notes before we get going. This machine here, obviously it's not usually like this. I have this covered. The plasma cutter itself covered. We're gonna turn that on. All right, I don't mess with these settings. We're at 60 amps. That's where we want it to be. And then this, we definitely don't want to adjust at all. All right, I'm the only one who messes with those things. But that's turned on. I want to turn on the communications with the computer. This here communicates with this machine. This one communicates with that machine. Okay, so I need to turn that on. And it turns on. My controller turned on there. And then this is making a noise, so I know this is on as well. Okay, this machine is usually tucked in this corner with a tarp on it. And you've probably been like, what's underneath that tire? Well, this is it. This is the machine. The CNC Plasma 2x2 water table. And it's on wheels, which is another nice attribute I like. I was able to pull this out so that it's out of the way. The water was all evaporated. Not all the way, but I had to go get a 5-gallon bucket, bring it in here, fill it all the way to where it's just right up to the top, about an 1/8 inch from the top. And now, to get even more ready, I can place my stock in here. I always want to double check too while I'm getting set up that my ground is grounded. So I have it attached here. It is in the water, but it's all touching everything. So my ground is good. So I'm gonna put this in here like that. All right. So that's basically how you get it set up. So Bongo here that I keep talking about, he's a character from the Wishtree if you haven't read him. But I 3D printed this. It took 36 hours just to print this. It's kind of big for 3D printing. And it's got a lot of, it's not hollow. There's some infill in there. But yep, that's that. All right, so now we're gonna move over to the controller. You're not gonna be able to see a lot, but just to give you an orientation, every time you turn on the machine, you have to send it to its homing station. And what that does is it calibrates the machine. There is a sensor here. Somewhere, there is another sensor right here. And when you home it, it ties into those sensors and just kind of trains itself. Okay, that's where those sensors are. Now we're good to go. And then you can do your origin and all those things. So what I'm going to do is set that right away. And it asks you right away, all home access. I'm going to hit OK. You didn't see it because it moved really quick, but it went to home base, which is the back left part. Now, if you look at this, this is actually made to be operated from the back side. X is going this way, Y is going this way. Not sure why they did that. I would rather be right here and be like X and Y, you know, type of thing, but it's the way it is. Just gotta flip it around and work from the back side. Okay? So now that we're homed, I can adjust my torch. I have my material in here. I can adjust my torch to the surface of my material. I also want to make sure it's level, which obviously it's not. I have this loose, so you can just make the little adjustments if you need it. There we go there. Just, it can get bumped. I keep this loose, that way if this hits something while it's turning, it can go boop and then move out of the way. If it was locked in, nice and secure, then it hits something, it's going to ruin stuff. So I keep it loose. It's not supporting weights or anything, so it's okay to do that. And then I level that off. Okay, next thing, I'm gonna lower this. Yep. So that it is just, hold on a second. So that it is about 1/8 of an inch, almost less than, above the material surface. Raise it up a little bit. Okay, what part about this that I don't like is that this table isn't level. I mean, if the floor was level, the table was locked down, it's on wheels, it's moving around. These grates here move around. So I can't assume that this thing's perfectly level, which means the distance between here and here can change as it moves around. So I just have to monitor that. What I need to do is bring this over and try to find the high point. Wherever there's the highest point, make my setting there, and then I should be good. But I'll do that off camera because that takes a little bit of time. All right, so in this case here, I'm gonna do some test cuts. Just like I was using the hand plasma torch in the Tech Ed lab, I'm gonna need some of these shaded safety glasses. Well, they're like safety glasses, but they're shaded, like sunglasses. So I'm gonna turn this on. I could do this all manually. If I wanted to just cut something and I want it to be a perfect straight line, I can use this machine for that without doing any programming or anything. I could bring in my material, get everything lined up, and then turn it on and hit the up button and it'll cut for me. So I can make really nice cuts using this machine rather than going in there and trying to rely on my hand or lines and different things like that. Because this thing's really precise. A piece of scrap metal, because I don't want to cut in my final product metal. So I'm going to cut into here. It's the same thickness and all that stuff, so that's good. And I'm going to turn it on. It's going to get loud and it's going to be bright, but that's okay. As you can see here with the controller, I can move this thing all around. All over. So what I want to do is put it on the edge because I don't want to waste the material. I'm going to turn it on and make a straight line cut just to make sure that my settings are correct. And my consumables are right. Here we go. If you look, they cut through that really fast, and the settings are right. I need to set my origin on my material, on my machine. All right, the origin is your starting point and where you want it to start. In the Cartesian coordinate system, or with the G code, it needs to know where 0, 0, where x equals 0 and y equals 0. That way it has a point of reference, like a starting point, like an origin, and it can go and cut out its part. And that way I can control that, hey, make sure that head stays on this material. If I put its origin right here, it could go and cut, and it's gonna cut off over here and stuff. Well, how do I know that? Well, that's because you didn't see in the designing phase, but my piece is 20 inches wide. Okay, it's kind of pretty big. And this is a 24-inch piece, so 20 inches will fit on here. Plenty. And then it's 16 inches tall. So if I move this to 16 inches and grab it from the bottom, there's 16 inches. I'm plenty fine tall, so I can move it up a little bit and then try to keep my margins the same on each side here. Another thing I need to make sure is my origin cannot start at the home position. It just needs to be offset a little bit. Remember in the beginning, I set it home and it goes all the way to the back corner and it sets right on top of the sensors. We need to move it off those sensors a little bit. It's not healthy for the machine. I don't know exactly why, but when I bought this, that's what the manufacturer said specifically over the phone. He's like, hey, do not start in the home spot. Okay, so I'm gonna move this around and then I'm gonna set the origin. Seems a little crooked. That seems good. Now I'm gonna come over here and hit the origin button. Changes everything to 0. Now when I move this around, let me turn it to high speed here. I can move this around. And if I want it to go back to the origin, now I can hit this green button. Do you want to go to the origin? Yes. And it goes back on its own. Right to where I told it to start, which is useful in some cases. Okay, now that I have origin set, materials in there, consumables changed out, machines turned on, all the designing done, the G-codes generated, now I can pull up my file and hit start. So I'm gonna do that, and you get to watch this thing cut. It's kind of fun. We're gonna hit OK, ask me again as a safety or a security measure as what the work speed should be. I already have that set, so here we go.